Welcome to our video for solution to problem 2C from quiz 7. So once again, we've been given the same series as in problems 1, 2A, 2B, and this time we're trying to show that the series converges using the root test. So why don't we quickly recall what the root test says. So the root test isn't much like the ratio test. You start with the underlying sequence of the series. So let's say this was what we called A sub n. So we start with the sequence A sub n, and we build a new sequence where we take the nth root of the absolute value of A sub n. And then we ask, what does this nth root sequence converge to? All right, so if this converges to something which is less than 1, then this implies that the series converges. And if this converges to something which is greater than 1, then the series diverges. Okay, and by the series, I'm referring to the original, right, series for A sub n. And of course, the sad one is that if it converges exactly to 1, then the test fails, just like with the ratio test. All right, so that means we're going to have to build this nth root sequence. So, and then we'll have to take a limit, right? Because we want to see what it converges to. So let's take the limit as n goes to infinity of the nth root of the absolute value of negative 3 to the n over 4 to the n plus 1. Okay, so first let's handle this absolute value. It's not going to affect the 4 to the n plus 1. That's already positive. And then this negative 3 to the n, well, anytime you have a negative and you have the absolute values, of course you expect those negatives to go away, and that's what's going to happen here. So we can get rid of the absolute values and get rid of this negative. We also have an nth root of a quotient, right? So we can instead take the nth root of the numerator over the nth root of the denominator. All right, in the numerator, we have the nth root of 3 to the n, which is just 3. That's fantastic. All right, so we have the limit, n goes to infinity, and in the numerator, a 3. In the denominator, well, I'm actually going to break this up as 4 to the n times 4. And now I can get the nth root of 4 to the n, but the nth root of 4 to the n is just 4. And then I'll have the nth root of 4. So this is the only place where we actually have an n involved anymore, right? We just have 3/4. So one of the rules that we learned in class was if you take the limit as n goes to infinity of the nth root of a non-zero constant, this is going to equal 1. So as n goes to infinity, the nth root of 4 will go to 1, and so this limit will be 3/4. 3/4 is less than 1, and hence by the root test, the original series, negative 3 to the n over 4 to the n plus 1, converges.